In this video, I'm going to be embedding plastic into a PCB like this stained glass shamrock. To do that, I need wire cutters, a small bowl, tweezers, plastic, a flat surface like this is the inside of a cake pan or spring pan, and some aluminum foil. I would recommend using a larger pan than this, but I can't fit much more underneath my camera, so I'm using a very small one. So the first thing that I do is I take the 3D printer plastic and I start chopping it into small pieces. And you can get 3D printer plastic for free from most hack spaces or fab labs, because this is actually just waste from when people change filament. So I pulled it out of the garbage at my local fab lab and my local hack space. Now that I have the plastic all cut up into small pieces, I take my flat surface, set this aside for a moment, and I take a very flat sheet of aluminum foil. Take a very flat sheet of aluminum foil and set it on the baking surface. And then I place my PCBs carefully on that very flat piece of aluminum foil. And this makes it so that the plastic doesn't leak out underneath the PCB. And it also makes it so you can peel off the basically the PCB with the plastic embedded easily from your baking surface. At this point, I preheat the oven to the melting temperature of whichever plastic I'm using. Usually you want to just use one type of plastic and not mix types of polymers, because they might have different melting temperatures or they might not stick well together. So then I just take the tweezers and I start placing the plastic into the PCB in whatever design I want. Now that I have all the plastic placed where I want it to go, I take the PCBs and I place them in the oven. It can take quite a while for the plastic to melt into the PCB. So just as a reference, this part of the video is running at 25x and it's actually missing a small part of the recording because I ran out of batteries. So yeah, it looks like it goes fast, but it doesn't. Once most of the plastic has melted, I take the PCBs out of the oven and I add plastic in the parts that don't seem like they have enough. And at this point, I can sort of squish plastic into the corners in places where it didn't flow very well. Okay, then I put it back in the oven, melt it one more time. I repeat the process of adding a little bit of plastic and squishing the plastic that's already melted into the PCB into the corners that it hasn't quite flowed into, and then remelting it in the oven until I get to a result that I like and I feel like the plastic is evenly distributed across the open spaces in the PCB. Once you have the plastic melted into the PCB, you take it out of the oven and then you wait for it to cool to about room temperature. So you can see with my thermometer that it's about 28 degrees Celsius. The hottest spot is 30.4. That's roughly kid doesn't have to go to school today temperature for everyone who's using Freedom units. So then I just take the PCB and I carefully peel the aluminum off of the back. And if you notice, there's a couple of resistors that have a little bit of plastic on them. And what that means is that when I actually solder this resistor on, I'm going to have to do a really good job of cleaning my tip on my soldering iron after each resistor, because burned plastic, it'll burn actually under the soldering iron, and that'll cause the soldering iron tip to oxidize really badly. So I'm going to have to clean it a little bit with flux in order to maintain a good soldering iron. But that's okay. It's not that hard to do. So now we have the PCBs in their finished state, or not really finished because we have to solder on everything, and you just follow the directions according to the other videos to do that.